Hello there, welcome to day 18 of the My Mate Vince Advent Amazon Return Pallet Challenge. So, another day, hopefully some more fixes. Can we make any money today? Let's find out. A massive thank you to everybody so far that has watched this series and also commented. Remember, I also did a series last year as well, not Amazon returns, just random stuff. So if you like the series this year, you might want to check out the series from last year as well. Anyway, day 18, let's get straight on with the very first, hopefully, fix.
Automatic hand dryer.
Here we have an automatic hand dryer. Let's unbox it and see what it's doing. Well, to me it looks like a new product, yet this was ripped open. I've just sellotaped it shut. That's the bracket mounting kit and also screws. It does come with a 3-pin plug, slightly weird shaped one, but in fact there's no fuse built into that, is there? No. Okay. Well, let's be brave. We'll plug it in. We'll see what it's doing. Right, I'm envisaging a bang coming up, or I'm envisaging maybe my electrics being tripped. It says 220 volts, frequency 50 hertz, power 2000 watts. We have a little on and off switch here, so I'll leave it off for the time being. We've got a sensor, and then we have the heating element in this bit here. So obviously when you put your hands under it, the sensor recognises and starts blowing. Initially, it looks quite nice. So let's plug it in. Let's see what you are not going to do. You ready? I'm in. I'm going to turn it on, moving back a little bit. Okay. Now, let's turn it on here. Okay, hasn't gone bang yet. Yes, it's not working. Brilliant. It's not working and it hasn't gone bang. So, let's take it apart and see what's happening. Always wary working on that mains product. I'm going to first of all test the switch here. Maybe the switch is faulty. And then looking at it, because it looks relatively new, but it definitely has had some use because I can see where the metal bracket was going up here. I think it's failed pretty quickly. Also, I've just noticed now, there's a bit of a shame. These have been knocked out here. Can you see there? We've got a couple of breaks here. So, but I don't think that's going to matter too much. It also looks like you can fix it to the wall with these points here. So I'm hoping it's still safe to use. Let's take it apart and see what's going on. I'm going to say it's going to be nothing too major. That's my prediction. Maybe a loose connection. Definitely had use. I can see quite a few scratches here now. Also, it looks like the crosshead screws are quite chewed up. There's one missing from here. So I'm wondering now, is it going to be... well, mind you, it should be all sealed. Do you know what I'm now wondering? I'm wondering, is it this that's faulty? So I think the first thing we should do is, before we even look at the switch, is check for continuity between here and the inside. Also, is that like legal? Like, UK plugs have a fuse in them. So, yeah. Is that supposed to be like that? So it looks like this whole front cover comes off. Oh, right, we have a little, looks like this strip at the front is lit up as well. So we have a connection going to it. Front looks immaculate. Let's undo that. Right, things to note is there's a bit of an oily fingerprint here, so that might mean something. It might be like a burnt component somewhere that's caused... Oh, okay, it's been cut. Oh, okay. So it was wired directly, I think. Hold on a minute. Why would they cut that but leave it in? Not quite sure what's happening here. Oh, sorry, that's the one I've just done. These are the main ones going into it. So if I was to connect these to these, then it should be okay. But I'm just a bit confused where the ground should go. It doesn't look like anything is ground. Is it double insulated? Oh, I don't know now. Hasn't got those boxes on here. You know, like a square and a square. I'm not sure now what's going on. I mean, you're messing with water, so I presume this would need to be insulated, but yet, is everything plastic? I think it is. Right, well I want to see this board here anyway, because we need to work out, I presume red is live, but we don't know 100%, so I think we need to get at least to the back of the board. So let's try to undo this one, this one, this one and this one. See what's going on. Let's just see if that switch is working. I'm not quite sure what's happened here. So I'm just going across the 2 prongs. Switch is working. And let's just go from here to the earth. Yes, that's connected through. This one is live. That's connected through. It's not shorted to there. And that's neutral there. And that's not shorted to there. Sorry, that's me pressing. That's me pressing the whole button. So that all looks good. Yeah, that all looks fine. If I had another one to copy, it would be easy peasy. I'm just slightly confused why they've bothered putting an earth wire in if it's not going anywhere. Because it would have been cheaper for them just to use a 2-core cable. Right, so that's that. Whoa, 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 whoa. So that's going to be for the motor. 220 volts, 50 hertz. So that's going to be AC, 65 watts. That's the heater element. We have a thermal fuse here, but I can't see the rating on it. I think it says 10 amp, 250 volt, but I can't see what temperature it is. And we also have one of those bimetallic strips. So safety wise, it should cut itself off if it got too hot, you know, if somebody covered up the output. See a bit of glue there, so you can see that there. I mean, that is all kind of, I think that's all looking okay. And that goes off to the board here. And then the other side goes off to the switch. So this goes down to the switch, comes back from the switch onto the board over here. And there we have some weird sensor thing, you know, for to measure your hands, a proximity sensor. Oh, there's quite a few chips on the back of this board, so maybe there is an actual problem. So even with nothing plugged in here, if we were to plug it in and do this, we should hear, shouldn't we? We should hear the relay click on. So we've got the live going down to this transformer thing. And then we've got this going to this massive capacitor, 1.5 microfarad. That's going to there, and that's going to the transformer. So I don't actually think it matters which way round it goes in this instance, because it's AC going into it. I can't see anything wrong here. What I'm looking at is, I'm just a little bit confused about this wire that goes off to the switch. Because clearly that's going to be 240 volts, isn't it, going through here. But there doesn't seem to be any demarcation between the lower voltage side. Or is none of this actually lower? Well, it must be lower voltage because of the transformer, no? What caps are these? What size are they? 35 volts. Is that not a little bit close to the circuit board? Should that not be... Should that not have a bigger demarcation across it, you know? No, I don't know. Right, okay, I don't think there's anything, I can't see anything wrong here unless the relay or something's failed. I think we need to wire this up, so I'm just going to get some Wagos for the time being. Alright, I'm going to strip this back and I'm going to get some Wagos. I'm going to push a little bit more through so I've got more to work with. We'll get some nice lever Wagos. Hopefully I've got some somewhere. So I get myself some of my favourite little Wagos. I love these little lever ones. They do a range of different wires. You just lift up the lever, put the wire in and close the lever. That's it, job done. No messing around with screw terminals or anything like that. So I put the brown live wire to the red wire from the actual hand dryer, and then I put the blue neutral wire to the blue wire from the hand cleaner, and then I just put a Wago on the earth wire just to stop it flapping around in the wind. It's already cut back, but it's just a little bit more secure. I would love to know what was in this originally, whether there was some kind of chocolate block type affair, whether there was some sort of push connector in here. Really don't know. So I had a quick look online, and the quick look, I could only see the outside of this product. There was no pictures of the inside, but I need to do a little bit more research on that. Anyway, we've connected it up now. I've put it back together because I don't want to risk shocking myself if anything goes wrong. And I'm going to be plugging this in from across the room because I don't know what it should be. And clearly as it is now, this is not how it left the factory. So I'm plugging it in here, and then I'm going to go across the room and plug this in. So I think right now it's not going to do anything, but then I'm going to come back and switch it on. Right, turn it on now. Okay, well, it hasn't gone bang, so now I'm going to turn it off, and I'm coming back over here and I'm going to turn it on. Now I'm going to go back over, and I think this is where you probably see all the lights go out. You ready? And reset. Okay, but it hasn't gone bang. Should we see now if the sensor's working? Oh, nervous. Oh, there we go. Oh, that was good. Hot air. And hand away, you can't see what I'm doing. Wow, I think it's working. I think I'm going to have to bring this elsewhere to show you it working. Well, I've got it balanced just on here. Do you know what I'm thinking now? I wonder, is this supposed to light up? I didn't actually see what was on the inside, but we have wires going to it. So maybe it's supposed to light up, and maybe that's why it's been sent back, because this is no longer lighting up. I don't remember that lighting up. Anyway, I am going to plug it in here now. I've got it balanced. Oh, we got a green light here. I didn't even realise I was on. Am I on? Hold on. Oh, whether you're on or off, that comes on. What? Hold on a minute. 1 second. Ah, yeah, it does light up. Right. Then it goes off. Now let's turn it off here. Now let's see if it's going to work. Oh, that's clever. It's cold. So when you have it off, it's cold. So that's purely for the heating element. And if you think about it, it was going through the heating element. So this is cold air. I'll get the flare cam in to show you. And then this one will be warm air. That's lovely. Honestly, that works so good, because every time I go into public lavatories, because I don't like those Dyson ones that you have to do that, because any bit of shake and you end up hitting all the wet hands full of piss that everybody else has been touching it there, because I know people don't wash their hands properly. They give you this much room to get your hands in, and I've got relatively small hands. But when you go to these style, you're like this all the time, you know, trying to get to work. This one works really, really well. Let me get you, but then again, it's brand new. Let me get you a flare cam to see. I'm now wondering in all these public lavatories, if they did a bit more maintenance and just cleaned the sensor at the bottom, I wonder would they work perfectly, because this is brand new and clean, and clearly it works perfectly. Right, I'm hoping you're going to be able to make that out there. Hoping you can see it on top there. So this is on the cold setting. And hopefully you'll see that my hand isn't getting any warmer. Yeah. Now I'm going to go onto the hot setting. Now, watch this. There you go. Can you see everything's getting a bit more red or not? Yeah. My hand's definitely... I'm going to have to pull it away a bit. It's getting warm. There you go. You can see now that is glowing red there. So why that was sent back, I have zero idea. Maybe somebody installed it and then just didn't like it. Maybe the business no longer, maybe they needed it for a weekend or something like that, and then thought it'd be just a good idea to send it back to Amazon rather than spending the money themselves. So if you could answer the questions about the earth cable in the inside, is that the right thing to do? Just clamp it with Wago, so it can't short against anything else. And also, what would you do with this one here? Would you swap that over to, it says on the thing here, it does say 250 volts, 13 amp, unless somehow there is a fuse built into here, but I doubt it. Would you swap that over to a UK style plug? I think I know the answer is going to be yes. Apologies, not that interesting.
15 pounds watt.
Here we have a mini sewing machine. Now I never got to look inside the last sewing machine because it was working. Hopefully, fingers crossed, this one might be faulty. Annoyingly, I can't test it because although it's got the foot pedal, it hasn't got the adapter with it. So let's bring it over to the mat and plug in a bench power supply and see if it's working. Look what I've just found. It runs off batteries, AA batteries. So first of all, let's do it with the adapter. So maybe it never came with an adapter. Let me see what the box says. Bobbins, foot pedal, needle, threader, AC, DC adapter. So it definitely came with adapter originally. So we are 6 volts, 1000 milliamps, so 1 amp. Center pin positive, and it's just your standard barrel jack. Right, I'm going to put the amps down to 1. There we go. So 6 volts, 1 amp. Center pin positive. Now, I think that is off, so it shouldn't go crazy. It looks like everything's a bit tangled. Now, are you going to work? Ah. Oh, look at that. It wants to, but it's getting jammed. Now, let's unplug it. Is that because, let's unplug everything. Is that because it's all, we've got a jam here, and maybe they just didn't bother freeing it? Do you know what? I might as well just cut this off, rather than spending hours trying to untangle it. Alright, so that's free there. That seems to be a little bit, like, in the wrong place, if you know what I mean. Maybe we'll undo that screw and see if we can sort that out. Okay. Right, let's put power in again and see if you're going to do anything now. No. No, it's getting jammed up. Why? Let's open this up. Is there something to do with this? Because this is turning. Right, let's unplug. I'm wondering if it's something to do with this. I'm going to undo. Let's try undoing this little screw here and see if that changes anything. Right, that seemed to just make a click. What is this for? I think I might need to watch a video. Oh, it's in now. Oh, it's stuck in. Oh, now we're going. So it is something to do with that. Right, let me plug it in again and see if it starts going. That was a fluke that popped out. No. So it's not that it's getting stuck now, but there's no power there. And we're going straight up to 1 amp. I'm just going to up the amperage just to try to see if we can sort of like break through that in case it's sticky oil or something. That's interesting. That's drawing 2 amps. 2 amps is extremely high though, is it not? Also, what does this do? That's not plugged in. Hold on. Let's just turn it on. Oh, it does. So it's working when we up the amps, but it clearly says here 1 amp, 1000 milliamps. And right now when I turn it on, it's drawing 2.2 amps, that's 6 volts. So what's going on? Do we need to get to the motor to see if the motor's ever so slightly jammed? Yes, Vince, yes we do. Remember, the power supply is 6 volts at 1 amp, meaning that's the max. The max. And this is, without even doing any stitching, so it's not under any strain, is 6 volts at over 2 amps, about 2.1, 2.2 amps, which is absolutely crazy. So if you were to power this with batteries, the batteries are going to wear out really quick. There's no way it should be over 2 amps. I'm just going to show you that now. What's also interesting is when we use the foot pedal part of it, everything sounds a little bit slower. Up the amps as much as they will go now, and it seems to max out at about 2.2. So if you listen to this, and this is on high. And that's low. This is high and low. And if we do the foot pedal, that's low. And this is high. So the foot pedal is definitely drawing lower amps, hence the reason it's going slower. There must be some drain down those wires. My oh my, I knew the box was cheap on this thing, so I knew it wasn't an expensive item, but you do get stuff with it. Like you get bobbins, adapter. Guess how much it is? It's sold as a portable because it's got batteries. So yeah, there might be instances where you may need a portable sewing machine. I can't believe how cheap it is. You ready? $14.99 for a brand new one. £15. I can't believe it's that cheap, considering you get an adapter with it as well, a power adapter. Right, I typed up this here and there is a few videos on it. They have huge amounts of views. I can't believe it. This thing is amazing. Look at this. Boom. That comes up there. This is to put your bobbins on, and then you do that to lock it into place and do that. So you're doing your windings and stuff. I think, although it does seem free enough, I'm just thinking 2 amps is a huge amount of draw, isn't it? I mean, how long are the batteries going to last at 2 amps? So I think what we'll do is, let's take it apart. A, because I think it might be quite nice to see the inside. This might now break it. I've got a feeling it's going to be more complicated than I'm going to give this credit for on the inside. But it will be quite nice to see. I'm just still in shock that they can make this for £15. That's delivered. So that's probably coming over from China. And then somebody's making money there, somebody's making money here. And a courier, a shipping company, has to, look at that, never fails me. Magic screwdriver working again. Everybody's making a bit of money. £15. It's even got a little light here that you turn on to shine a little LED down. So the original fault here was that the needle wouldn't go down far enough, and that's just because it was getting jammed against that bottom bit. But there's no way it should be drawing over 2 amps. So if the previous person was using this with batteries, the batteries would have drained really quick. Or if the power supply that they got was a 1 amp power supply, then if it's going to work, it will be extremely weak. And I don't think it would take much to stop it at all. So let's have a look on the inside, and we need to have a very close look at this motor to see what's drawing so much. Is it the motor, or is it the gears connected to the motor which are all gummed up that's causing too much strain? Oh my word, I was not expecting that. I thought that was going to be much harder. Well, initially, unless the motor's playing up, I can't see anything wrong with this. Everything looks... Everything looks okay, doesn't it? You know, it's amazing seeing the inside of stuff. I was expecting more springs and stuff in it. To me, there's nothing there that feels overly stiff. But I suppose what we'll do is we'll start taking gears out of the equation and see when it gets easier. Maybe this should be just spinning around really, really easy. So, to begin with, should we take out this bottom piece? And now let's see. So that's no easier. I think it's from up here that the roughness is coming from. So let's start dismantling. Let me take a picture. It's one of those things where I think it's going to be very hard to put back together unless you know where things go. So I think we need to take off all the gears here and see if the motor itself is finding it hard to spin. So that's off there now, and let's take out this completely. So let's see now if it is going to be working at 2 amps still. Well, here goes. Let me use this, it's easier. Yeah, it's 1.8 amps. 1.5. So it looks like it's the motor itself which is drawing all that. It's really weird. So now let's see if I can take this off here. How do you come off? Here and here. Now let's see if it's still doing that. I think this is a good way of doing it. Yeah, 1.8 amps. So the motor itself is the thing doing all the drain. So the motor itself is not happy. So I think we need to get the motor out and then go straight onto the contacts off the motor, and that eliminates anything to do with something weird going on in here or any of the switches, because maybe it's some switch that's not working very nicely. I can see a switch here with a diode across it. Here. This is for the high and low. So is the diode there to just drain more power? And is that how you're getting the low speed, just by converting, you know, the drop off the diode? Is that what that is? What would be nice is if the motor itself doesn't take that much, and then we know it's something. For example, could it be, should I quickly go across the diode before we take anything else apart? Just in case the diode is some, I don't know, shorted or something. So I'm on diode reading there. Nothing that way. And a reading that way, so I think that's alright. Right, we have got to the motor. I'm going to take a picture. I want these wires off it. So we've got the thin green wire and the fat blue and the fat green on that side. Now I'm going to get a Sharpie because I want to make sure I solder it back on the correct way, on the correct terminals. So I'm going to put a mark on this one here and this here. Right, we've got our motor out, which is good. So now what we can do is we can put the bench power supply on the motor and see, is it just the motor that's draining the power here? Here. Wow, 3.9 amps. 3.9 amps. Crazy. Right, let's go this way round. Whoa. 3.9 amps. That is not right. And is that at 5 volts? 5.7 volts, 3.9 amps. I don't want to leave it on that long. Right, 100% the motor. That's not right. So I think we're just going to have maybe a lot of arcing on the bushes. Brushes. Or does it just need oiling? Let's try to take it apart and see what's going on. That's very high though, isn't it? I'm still in shock at $14.99. It's unbelievable. Right, what do you think we're going to find? I think this has probably had, jeez. Oh, I got myself there. I think it's had a lot of use. I'm going to say that that's gummed up. Hold on. That feels crunchy, listen. Or is that because it's against that? I think maybe the oil has gone a bit gunky. Can I take that off or am I going to break it? I'm really wary when I see these little, I've had such bad luck with the nylon gears. But can you see there's horrible grease there? It might not be horrible, but I'm wondering whether it's gone... That came off easy. I'm wondering whether it's gone very stiff. Right, so I need you to come out. Ow! Oh! What was that? That's a little washer. Why did that hurt so much? There we go. I am going to give everything a clean. So I give it all a nice good scrub. I get my Q-tips out and I get rid of all this black gunk everywhere from the brushes and also from where the bearings are, you know, these kind of like little coppery brassy bearing type things. And yeah, what I then do is I get some silicone grease that I've only found recently. I used to have this. I'll tell you how long ago I bought this. I bought this when Maplin was still a shop in the UK. And as far as I know, I think they've been closed down for a good 6, 7 or 8 years. So I've had this grease a long time. The lid came off it many years ago and it's been stored in plastic bags. So I'm going to grease everything up with this. And then hopefully then it's not going to conduct or anything, but it will still allow a little bit of lubrication. Right, so I'm going to smear it around the brushes. Like so. And I'm also going to put it on the end bit here, I think. Or should I use oil for that? You know what? No, I'm going to use oil for that because the thing is, this isn't a lubricant, is it? Oh, it says excellent lubricant. Ooh, okay. It does say it's excellent lubricant. Well, let me try. I can always put a bit of 3-in-1 in as well. They might mix together. I don't know if they like each other. Right, I am going to put that in here. Like so. I haven't put much of this on anyway. Put that little rubber plastic washer on. I think it went there. Now, I've got to try to get these brushes. I didn't make a note of which way this goes on. Uh-oh. Well, it doesn't matter, does it? It doesn't matter. I just have to make sure that that tab goes there. So that's got to go there. Right, so it's got to go on that way. Now, do you see these little ones here? I need to open them up because otherwise they're all going to get mashed up as they go onto that. So if I get these in these little oblong holes here, and if I put it in the right way, I should be able to. So that needs to go this side, and that needs to go that side. There. Now watch, can you see? It's opened itself up nicely because I can bend them like that. So I'm going to hold it like this, make sure I've got my little notch again. So the notch is here. So the notch is going to go there, so it's got to go on this way. That's annoying, I don't know if they went on right or not. No, I don't like that. I nearly had it. Actually, why don't I do this? This would be much easier because I can see what's going on. I'll push it out here, walk it on, like so. Now I know they're making a contact. Oh, there we go. Do you know, out of all the times I've messed with motors, I never thought of doing that. That's beautiful. Better than using that technique there. You kidding me? It was still at 4 amps when it was working. What?
Ha ha.
What's going on? So not only is the amp draw as high as it was before, but now the motor's not working. So I'm thinking, could it be something to do with the silicone grease? I leave it on the brushes, but I'm going to put oil on the actual bearing parts. So I clean it off the bearing parts, and I'm just going to use 3-in-1 oil. So I know the brushes are worn, but I would have thought that that wouldn't affect it that much. Right, let 3-in-1 oil do its magic. Could it be as simple as this? That's annoying. Sounds better, but it's still 3.9 amps. No, so it's not. So it wasn't the grease, and it wasn't the oil. Nothing like that. It's the motor itself has failed. Yeah, it's red hot. Well, not red hot, but it's very, very, very warm. Right, look in here. It looks like the coils. So what I'm thinking is the coils have joined together. So no longer is it, for example, 50 meters of enamelled wire. I'm thinking it's it might be like 10 meters or something, or 5 meters. I think some of it is partially shorted. This looks nice and coppery. These two look very dull. But if you have a look, can you see this particular coil here? It looks like we have the wire coming up to this point and this point here. And I presume that is to do with this bit of the commutator. That's to do with this bit of the commutator. Now look at this one. It's this one, and again there and there, and here, there and there. So we should be able to go across here and here, and here and here, and here and here, and see if we have the same reading. We should have, I'm thinking, the same reading on all of them. There's a few people saying, Vince, just buy a new motor. I know I can, but that's not what my channel's about. I tried to find out what's happened and if it can be fixed, even if it's not economically viable. This whole sewing machine is not economically viable. You can buy a working one for £15. But I make my money from the videos, not from the items. Right, so let's go across this coil here on ohms and see what we have. So we've got 0.8 of an ohm. Now let's go to this one. 0.8 of an ohm. Now we're going on the nice shiny one. it's even more of a short. Now does that suggest something that we have 3 different readings? What's that about? Why have we got on the shiny one? I would have thought that the other two had shorted, so we'd have an even more direct, you know? Because my leads are 0.2 at the moment. Let's see then. So if we go across here and here on the commutator, that's 0.3 here and here. So we have an imbalance there, don't we? I'm going to try to scrape out in between the commutator just in case it is given some kind of weird short. I don't know how to fault find this any further now. No, I don't know. I don't know what to do. Unless the shiny one should be 0.8, and it's that's causing the problem. I think I'm going to unsolder them. from here. I think this motor's scrapped now anyway. I can't see what else could be causing it. Everything's getting very warm. I think it must be the windings. So what I'm now thinking is that here we should have 3 windings, and there might be, I'm not sure, 50 meters of enamelled wire here. But let's say now if that enamelled wire has shorted together, it might only be the same as 1 or 2 meters of enamelled wire, and maybe that's why we've got such a draw on the bench power supply and the motor's getting so warm. It's the same essentially as shorting the wires together. So from the bench power supply, it's the same as getting the 2 wires and just putting them together. We nearly have a direct short. Yes, the motor's working because 2 of the coils look like they might be okay, but if the 3rd coil is not right, then maybe that's where we're getting this massive draw from. And it's the same when it's in the sewing machine. It's the same, similar to touching the 2 wires that feed the motor together if the coil is shorted. The only thing is, the coil that's giving me a different reading looks lovely. It's the other 2 coils that are giving me the 0.8 of an ohm reading that look all dull and burnt out, because I would have thought a nice coppery coil is the way to go. The single coil, which is testing different, looks good, yet it's got more of a short on it. So a 0.3 of an ohm short is more of a short than a 0.8 of an ohm short. In a perfect world, if my multimeter was fine, it would read 0 ohms, meaning that there's no resistance at all. But there will always be a little bit of resistance because of the leads from your meter. My meter, you can't zero out the leads. But you see, I'm going across these coils, and I'm getting 0.3 of an ohm on the shiny one and 0.8 of an ohm on the other 2, meaning the other 2 have more resistance than the shiny one. Right, so this coil, the shiny one, is measuring 0.4 of an ohm. This dull one, 1.4 ohms. Yes, yes, yes. And this dull one, 1.7, 1.4 ohms. Let's do that again in case my fingers were touching it. 1.4, shiny one, 0.4. So now the question is, have the other 2 failed, or has the shiny one failed? I'm going to say the shiny one purely because the motor is working, and if the other 2 had failed, would the motor work if there was only 1 coil working? Probably unlikely. So although the shiny one looks lovely and the other 2 look horrible and dull, the shiny one I think is faulty. So what I'm going to try to do is I'm going to try to unravel all 50 meters or however long it is of enamelled wire on the faulty shiny coil, and then we can measure it when it's unravelled, because you see it's shorted against itself. Yeah, imagine if the enamel was off and you just wound some copper wire around a piece of plastic, well then it's all going to short next to each other. But that's why you have the enamelled on the wire, to stop it shorting next to each other. So when it's unravelled, it should measure 1.4 ohms like the other 2 coils. Then we know 100% that that is the faulty coil. Yay, we're out. We're out. So this one now is completely empty. There's not as much of it as I thought. I honestly thought there'd be about 100 meters, but there's not. It looks to be maybe 4 meters. Let's see what it's reading now. Apologies, this was the day when I had the worst hiccups, and I had them all day long apart from a few hour breaks, but they kept coming back. Look at that. That's proved it. 1.3, yet remember it was 0.4 before. So this coil shorted, I'm sure of it. So the wire itself is fine because it is no longer wrapped up next to each other. Somewhere this shorted next to each other and was drawing too much current, the same way as the wires going off to the motor, you know, these ones here, touching together because it was a direct short. But now that I've unwound it, it's testing 1.3 like all the others. Do you know what I'm thinking? What's the odds? There's only probably going to be, let's say if it was shorted, the whole lot of it's not going to be shorted. I mean, what would be lovely is if you've seen a part that was shorted, and then you could do this. You could go along, yeah, and do, oh my word. What did I say? Look at that, there. So where's the enamel there? It's gone. Imagine if that was the area. No, there as well. But remember, I have peeled it off. Depending on how many places it's gone, because I'm not going to rub nail varnish over the whole thing, and I haven't got this gauge. The thickest gauge I've got is this one here, which is 0.3, which is a lot less. This is what I'm thinking. Nobody in their right mind would do this. I'm doing it purely for the video. If I was to wind it up again, what's the odds of it being in the same spot? You know what I mean? So right now there's probably 10 or 15 bits along here that are shorted with no enamel on. But if I wind it, as long as the bit with no enamel is not touching another bit with no enamel, then I think it will be okay. I presume it might heat up and go again shortly, but it'd be nice just to see if we can get the motor working on a low amp reading. Now, do you know what I didn't take any notice of? Which way round it needs to go. So this one needs to undo clockwise. This one needs to undo clockwise. So that means we need to do this up counterclockwise. So I'm going to leave a lot of slack, like so. And let's get these well out of my way, because it's already going to be hard enough. And humour me while I try to redo it. So I'll just fast forward through this bit now. I'm just going to wind it all up counterclockwise, so anti-clockwise. And then, yeah, I've just got to do it as tightly as I can. And I've got to keep moving the wire in and then out so I don't bundle it up all in one bit. I'm trying to like spread it out across the actual motor itself. Obviously, it's not going to be as neat as it was in the factory, but I can't have it sticking out proud off the magnets, because otherwise it won't turn. It's just going to short, isn't it? And it's not going to be able to turn. So I've got to make sure I wind it nice and tightly. It actually goes on quite nice. So let's cut to the video now when I've finished the winding. Now, because I've started in a different place, the odds of the bits that are shorted, you know, where the enamel's off, would be very unlikely, because let's say if they all happened on a bend, well, now that I've kind of pulled through this much, that bend should now be on new bits of copper, I'm thinking. Right, let's see. So we got this one here, and let me unravel this. Right, so this is my new one here. Let's see if it's now reading 1.4. So please be 1.4. You beauty. You absolute beauty. Oh my word. Right, let's try to solder them back on so that they're all crossed. And then you never know. It might work. So to begin with, I just solder up the shiny coil, the faulty coil, and then let's check it straight on the commutator, because that's what the brushes are going to see. Right, so none of the others are going anywhere. Let's see now if I go between this commutator and this section of the segment of the commutator, are we going to have 1.3 ohms? Right, let's see now. Do I have a reading here and here? You beauty. That's fantastic. Oh my word. I am actually excited This is, I already love fixing stuff, but this would be amazing. So I then solder up the second working coil. What I do is I put the enamelled wire around the little bit sticking out by the commutator, so I'm wrapping them, and I'm holding the soldering iron on for a long time to make sure it's burning off the enamel so it can get onto the copper inside the wire and then solder the copper to the bits that stick out. And then I test it. That coil's also testing okay. But then it's a My Mate Vince video, so we have a little hiccup on the third coil. Uh-oh. That's not going to be long enough to get over to there. That one needs to go to here. But that one needs to go to there. What did I do? Did I cut it way too short? I don't want to fail now. Ah, do you know what I should have done? Oh, I should have made sure this was up here before I wound this. What I've done is I've bulked out this too much, so this can't lie flat now. So I'm going to have to try to add a little bit to that, because I need to get that to go over to here. So let's do this one first. That's disappointing. I'm putting loads of solder in the hope that some of it will melt the enamel away. Right, we've got all this wire now to use to try to join this to here. That's a real shame, that. A real shame. Anyway, I might be able to, it might work, I might be able to put a bit of nail varnish or something on it. Let me try some flux. Right, it's not the best, but it might do. Do you know what? It's not bad. Right, so that needs to go over to here, and I need to make sure that I need to put nail varnish on that. Is it going to shorten anything else? Let's put a little bit of nail varnish on it and crimp that down there. I wonder would a tiny heat shrink work on that? I have got tiny ones. Yes, why not? Let's give it a go. So I've got to make sure that this doesn't come wider than here, because otherwise it will rip off as soon as the motor starts turning. Like, why don't I put that there, and hopefully I can bend that right the way in. Is that going to work or not? Might be too big. Let's keep it here. That might tuck in. So let's just do it just here. Oh my word. I've rewrapped it. And that should clear that. So shall we go across all the segments now. Because that's not on anything there anyway, is it? No, it's this that's going to be doing the oil here. Right, let's go across all the segments now and see what they're doing. I really do have my hopes up. I need to remind people, I know it's not worth fixing a £1 or £2 motor. It's just the enjoyment of doing it. Right, these two segments, please. Brilliant, 1.3. Roll it one lot round. These two segments. 1.3. Roll it one lot round. The last two segments. Yes! Come on! That's amazing! You have to give me that. Imagine now if it doesn't work. Please, please, please work. This will be my Christmas present. Okay, I won't worry about oil. I just will do what was already on here. I feel nervous, like I did years ago when I was doing something like a chip for the first time. Because I have no idea if this is going to work or not. We're on. Are you ready? Oh, let's just put this on here so we can see it spin more. What do you think? Yes or no? Yes or no? I'm going to say yes. I'm just at 3 volts at the moment. Please don't draw massive. Oh my God. Oh my God. It's 250 milliamps. It's 250 milliamps. Let's go the other way. 265 milliamps. I've got to show you that. Hallelujah. It was up to, I think, 5 amps. Well, I'll tell you what. Let's go up. Let's whack the voltage up. We were at, I'm just going to do 5 volts because I don't want to push it too much. I don't know what this is actually outputting. I presume 6 volts, but I don't know that. Well, actually, it should be direct from here, so it would be 6 volts. Oh my word, 350. 330 milliamps this way round. I don't care, that's noisy. 330 milliamps. Come on, Vince has fixed it. So I'm going to be putting this against here and I'm going to be showing you the bench power supply. All right, let me get my mate Vince Coke can, exclusively for me. There. Watch this. Hopefully you can hear it. 350 milliamps. 1/10 of what it was before. Now let me go here. No, it was, what was it? It was 2. At 6 volts, let's go up to 6 volts. At 6 volts, it was 2 amps, wasn't it? No, but it was more, wasn't it, when we were directly on it? Listen to that. I don't want to push it too much. That's amazing. I've learned to check for motor windings. Can't tell you how happy I am with that. So I am going to solder this back up, put it back together there, and then what we'll do is we'll see when it's all back together from my bench power supply what it's drawing now. So I'm going to have to refer to my phone and stuff. Next time you see this, the motor will be in. It's going to take a while to put it back together. And also I just have to bend these things over. That's amazing. And I'm going to add a little bit of 3-in-1 oil to try to make it a bit quieter. Actually, let's just run it now with the oil and with the back closed, see if it sounds nicer. I'm dropping it to 5 volts. Oh yes. Not too bad. Let's go the other way. Even nicer. I know the brushes are still worn. But, oh, that's just so good. Right, next time you see this, it will be back together.
Showtime.
Here it is. I think this is worth every penny of £15. Just operating with batteries at the moment. that's high speed and low speed. I love that. And just to show you the amp draw when it's plugged into the bench power supply, let me just cut to that part of the video now. Right, so I'm going to do low speed to begin with. Yeah, you can see there, that's the amp draw there. So 0.6 of an amp, while before that was about 1.8. And if I go high, I think it was 2.2 amps before. Now it's 0.7. Love it. I'm so happy with it. I just wish I knew how to use the thing.
Summary.
Right, unfortunately monetary wise it hasn't been the best day. I can only put that hand dryer down as £12.50. They retail at £50, but I don't know what the inside's supposed to look like, so I would only be happy with friends and family for that one. And likewise with the sewing machine as well. It's far from new, so retail £15, a quarter of that is £3.75. So grand total of £16.25. So yeah, not a great day monetary wise, but personally I really enjoyed the sewing machine. Let's see what day 19 brings.